Hello everyone. In this video, we will be discussing a relatively new AWS KMS feature called KMS Grants. This video is relevant for IAM administrators or cloud security folks or anyone in general interested in permissions management in AWS. So what are KMS Grants? Grants are a temporary mechanism to provide key permissions to AWS identity. This is in contrast to KMS key policies, which are meant to be more of a long-term measure. So when you're assigning permissions to a AWS KMS key, always keep in mind that there are two ways of doing it. One, via KMS key policies, and two, via KMS grants. To dig further into KMS grants, let's take a look at the KMS access control model first, and then see how this model changes when grants are being used. So in the traditional KMS access control model, which you should all be familiar with, whether you are providing access within a single account or you're providing access across multiple accounts, you need to grant the specific permission in both the IAM policy as well as the KMS key policy. So think of this as a math equation, right? The IAM policy in this diagram, which is attached to role XYZ, needs to provide KMS decrypt on KMS key 123, and the resource policy attached to key 123 also needs to provide KMS decrypt to identity role XYZ in order for the final permission of KMS decrypt to be allowed for that role and key, right? So this is both permissions are need to be provided in the IAM policy as well as the KMS key policy. Now, when grants are being used, they provide an alternative mechanism for permissions to be granted for the KMS key. And that is without any need for updating the KMS key policy. So the equation now changes to you need to provide permissions in the IAM policy as well as either in the KMS key policy, or you need to have a grant created. So the total permission provided by key 123 in this example now includes the sum of permissions from both the KMS key policy and KMS grants. If these permissions are also allowed in the IAM policy attached to role XYZ, the operations will be permitted. At this point, you might be wondering why grants are needed when KMS permissions can be allowed using key policy. Good question. There are two main benefits of using KMS grants. KMS key policies represents the permissions attached to the key, to the KMS key, but are designed for long-term permissions. However, cloud infrastructure sometimes desires situations where temporary access to the KMS key is required. Example, a short-term data migration project or an automated maintenance project like backup. In these temporary situations, KMS grants is extremely useful. Another security benefit of using grants is the fine-grained access model that they provide, right? If you have used KMS key policies, you might be aware that you can provide star or use full or provide full access to the key to any identity using KMS key policy. So from a security standpoint, the blast radius of a ill-configured KMS key policy is full administrative access to the entire key. However, when you're using grants, the exposure is very limited because you can only create grant for the specific operation only. And we will also see this benefit later in the video, so please do watch the video demo for that. These are great benefits, right? But are there any security risks when using KMS grants? So remember when I mentioned that KMS grants can only be created for temporary access, right? This is only partly true. While the original purpose of grants is to provide temporary access, currently there does not appear to be any way to automatically expire a KMS grant. So once a KMS grant is created, it will continue to live forever. Even though the purpose for that might be temporary, there is no way to automatically expire this key. Now, this presents a significant security risk from a cloud security standpoint. That is, if you're not actively monitoring or deleting these grants, it can lead to vulnerabilities for encrypted resources. So keep in mind, grants do not automatically expire, and security auditors must monitor unused grants. Again, we'll see this in action in our video lab as well. All right, so let's take a quick look at the blueprint from this demo where we will be creating cross-account S3 access using KMS grants and key policy. So in this setup, we have two AWS accounts. One is the data account, which is hosting the S3 bucket. And then we have the Accessor account, which is hosting the IAM role that will be accessing the contents of the S3 bucket. Initially, we would establish cross-account access to the bucket object from the IAM role by adjusting the S3 bucket policy and the IAM role policy. At this stage, since the bucket is not encrypted with KMS, the access would succeed. Next, we will enable KMS encryption on the S3 bucket. And since at this point, using the KMS key is using the default AWS provided KMS key policy, when we try to access the bucket from the role, the access would be denied since there is no KMS permission allowed to be allowed. Then we'll be looking at two solutions to solve this problem of encryption using, first of all, by adjusting the KMS key policy. And then the second solution would be using KMS Grants. And this will allow you to compare and contrast these two solutions and further understand how and when KMS Grants could be used. So without further ado, let's start the lab. So let's start our first part of the lab where we would be creating the S3 bucket that can be accessed from a different AWS account. So I'm logged into my first account, which is called data, and it's ending in 6803. This is the account that will have the S3 bucket. And I've also logged in an incognito tab to the Accessor AWS account, which is right here. And this account, as is called Accessor, and this will have the IAM role, which will be accessing the S3 bucket, and it's ending in 5404. Also, I have logged into these accounts from the command line or the Mac terminal. And in order for ease of usage, I'm using profiles to signify these accounts. The first action that I'll do is I'll create the S3 bucket and upload a demo object within it. So I'll use the S3 MB command to create my CSM bucket demo bucket. And again, as you can see, the profile here is data. So I'm creating this in the data AWS account. And with my bucket created here, let's just verify if it's there. Yeah, the bucket has been created. And now I'm going to add an object inside this bucket, which for that I'll have to create a local file called text.txt, and have some mention some demo text within this file. And now I'm going to use the cp command to copy this object into my S3 bucket. So with this object uploaded, let me go to the AWS console and verify if this is the object is there as expected. So I'll click on my bucket name, and I should be able to see my object there. Yes, there it is, test.txt. And I'll click on this object and then click on open to verify that my demo text is there as expected. Okay, so now I will be creating the IAM role in the Accessor AWS account. So first I'm going to create this trust policy locally. And then I'm going to be using the create role command and provide the role name of cross account S3 read and attach the trust policy document that I created. And this role would be created in the Accessor AWS account. So that's the profile I'm using. And with that, my role is created now. And next, I'm going to add permissions to this role. So the permissions that this role needs is the S3 get object permission on the CSM bucket demo. So we'll create this JSON locally and then use the IAM put role policy command and add this policy JSON to this role. Right. Again, the profile here is of Accessor user, so we're working in the Accessor AWS account. So with that, our role and the policy attached to is created. In the AWS console now, just verifying these changes from the console. Here is my cross-account S3 read role that I just created. I can see the trust relationships as I specified. And if I go to permissions, I should also be able to see the S3 read policy role with the required S3 get object permission on the relevant S3 bucket. The final thing that we have to do here in order to make the S3 bucket accessible from a different AWS account is to update the bucket policy. So I'll be creating this bucket policy JSON locally, and what this bucket policy says is that it allows S3 get object on all the resources within this bucket to the IAM role that we have created in the Accessor AWS account. And then I'm going to use the put bucket policy AWS command to apply this bucket policy to my S3 bucket. So with that done, let me quickly go to the console and verify this. And if I click on my bucket name, go to the permissions tab, and I do see the bucket policy that I applied in command line successfully reflected in the AWS console. So coming back to the command line, in order to verify if my access from the IAM role is working as expected, I will need to assume that role. So I'll use the sts assume role command. What I'm doing here is that this assume role command will export the credentials, so the access key ID, the secret access key, and the session token. I'm storing all that in an output JSON called assume role output.json. And then I'm using some jQuery magic to be able to pull those credentials to my local environment variable. And then I'm setting the AWS configure with these assumed role credentials. So now I have a profile called assumed role that has the access key ID, secret access key, and the session token of the IAM role that I have assumed. So now, in order to finally verify the access, let's just first confirm if my identity is successfully set here. So I'm going to use the sts get caller identity command and put the profile of assume role. And I should be able to see that this is the account accessor, which is ending in 5404. And I have using the cross account S3 read role here. So this is working as expected. And what I'll do now is I will use the cp command to try to access the S3 bucket using this assume role, and I will try to download the demo object. So the object is downloaded successfully, and let me verify if the contents are there. So yes, my demo text that I have put, I'm able to download that, and so my cross-account access from this IAM role in Accessor account to the S3 bucket in the data account is working as expected. So now we are reaching the crux of this lab, which is to deal with encryption. And till now, the S3 bucket is not encrypted. So the cross-account IAM role is able to access this S3 bucket. So let's try to enable encryption on this bucket and see what happens now with this access, right? So for encrypting this bucket, we first need a KMS key. So let's just create the KMS key first. I'll be using the create key command in the data AWS account to create the KMS key. This is the standard encrypt decrypt KMS key. And I'll be copying the KMS key ID so I can use that later on. The next step I'll do is that I'll use the S3 command for putting this encryption to the bucket, which is the put bucket encryption command. And I'll be specifying the bucket name here and the key ID that I copied from the previous step. So with that, the bucket should now have the default encryption using this KMS key. Let me quickly verify that from the console. And so as you can see here is SSC KMS is enabled using the encryption key that I created. An interesting thing happens here is that even though the bucket has default encryption with KMS key, existing objects in the bucket would still continue to use the original encryption mechanism. So now we'll have to go to the object, which is the text.txt, and go to the settings within that object and enable KMS encryption using the KMS key that we created in order for that particular object to be encrypted with KMS. So with that done, now let's go back to our command line and do the same cp command that we were doing before and try to see what happens now. And so now we are getting an error. Now, till this point, we haven't really dealt with KMS permissions. So whatever AWS offers by default, we were just going with that. Now, as you can see, we are being thrown an error that, hey, you do not have the KMS decrypt permission for you to be able to copy this object, right? So that's where, that's the issue that we're going to be solving in the next part of the lab, where we'll be using the two solutions for this. One, via the KMS key policy, and two, via KMS grants. In order to update the KMS key policy, we need to update the default policy that's provided to us by AWS. So here you can see that I've created a JSON locally in my command line with the updated key policy that I want to update in the KMS key. And as you can see here, the second statement here is what's there by default, which I will link a video to the same topic in the discussion, which goes into the details of what that statement really means. But basically, that statement is for intra-account access to this KMS key, and is basically delegating the access for all intra-account needs to the AWS IAM policy. Right. So for our use case, we need to have a cross account permission. Right. So that's why we've put another statement there, which is the statement one. This one provides the KMS decrypt permission to the cross account role that we have created. So now I'll be using the KMS key put key policy command in order to apply this updated key policy to my KMS key ID that we have been working with. So with that done, let me go back to the console and verify if the permissions have been updated as expected. So as you can see, the key policy here now has the two statements. One is the default one, and the other is the cross-account one that we have recently updated. So with that done, do you think that the copy command that we were running before would now work? Right, let's find out. And the answer is no. So as we discussed before in the introduction, when you're working with the KMS policies cross account, you need to update both the KMS key policy as well as the identity policy. So now we have to create an inline policy or IAM policy for the IAM role, and we need to attach it to the cross account role for that role to be able to have the KMS strict permission. So I have created this JSON locally of what that permission looks like. This is again similar KMS decrypt permission, and we are providing the KMS key ID here. And then I'm going to do the IAM put role policy command to apply this policy to my IAM role. With that done, if we do the CP command now, that should go to success. So as you can see, that's working as expected, right? So this was the solution to the problem of missing encryption using the KMS key policy update. Now let's take a look at the fun and the last part of this video, where we would be using KMS grants to update the key permissions. And this will allow you to compare and contrast the solution with the other solution for using KMS key policy. So before we even work with grants, let's try to revert all the changes that we did for the KMS key policy. So I'll be reverting the KMS key policy that I created earlier, and I will bring it back to the default state, which is provided by AWS. So I will use this put key policy command, and as you can see, the policy here is the default one that's provided by AWS. And after I do this, then I'm also going to remove the identity policy that I applied to the IAM role. Now keep in mind that we might need to put this back on later, but I'm just trying to reset everything so that we are on the same page. And so I'm going to apply this updated key policy, or just remove this I'm going to remove this IAM policy from the IAM role. And let's try the CP command now, just to see if our error that we were receiving from missing permission is back again. So yeah, we are on the same problem that we had earlier before we updated the key policy. Now let's take a look at how grants could be used to solve for this. We will be creating the grant using the create grant AWS command. and we'll be obviously passing the key ID here, and the grantee principal would be the cross-account AWS role that we want to provide KMS permission, and the particular permission that we'll be providing is the decrypt permission. Now, I'd like to pause here to talk a little bit about one of the key advantages of KMS Grant, as we discussed in the introduction, was that it allows you to have fine-grained access control over the key permissions, right? And this is exactly the reason why. Unlike key policies where you have the ability to be able to use star, and that pretty much gives you full access to the KMS key policy, when you create grant, you have to specifically specify the operation that that the grant would be used for. So in this case, we're using decrypt, right? So this is the reason why grants can have a lesser blast radius as compared to key policies, and they are much safer and more secure to use. Right. The other option here is obviously, since we're doing this in the data account where the S3 bucket is, where the KMS key policy is, we'll be using the profile of data. So with that, the output of this command is the grant token and the grant ID. Now you don't have to use the token. It's basically used for situations, but there are situations where sometimes the grant takes a long time to create. So if you have a process that is running, you're trying to use the grant instantaneously, so it might not work like right away after you create the grant. So in those cases, you can use the token. But if you just like me testing it out from the command line, you don't have to use this token at all. So with the grant created, let's try and run the CP command again and try to access the S3 bucket and see what happens. So we have the error again, but if you notice, it's not pointing out the missing resource permissions now. It's pointing out that there are some identity-based policy that is missing permission. So that means that the grant from a resource standpoint, the permissions from the resource standpoints are there. We just need to add the permissions to the role or the identity. So let's do that next. So this is similar to what we did for the KMS key policy. We're going to create an inline policy which allows KMS decrypt permission on the KMS key ID, and we'll be using the put role policy AWS command to attach that to a policy to the IAM role. And we'll obviously be working in the Accessor AWS account for this. Once this is done, if you run the CP command now, there you go, it works. So what happened here, right? Let's go back to the AWS console and see what permissions are visible from there. So if I go to the key policy here, as you can see, if a security auditor is looking at this key policy, they would just assume that this key can only be accessed from the same AWS account, because there is no mention of cross-account permissions here, right? And there is no tab here that tells you that the grant has been created or there are additional policy permissions, right? So this, from a security standpoint, is a grave security issue. And this is also something that we talked about in the introduction, where we said that if you are a security auditor or responsible for the permissions management for your organization, be mindful of these grants, because they, as of today, they don't show up in the AWS console. The only way for you to be able to see these is if you go back to the CLI. We can type the AWS KMS list grants command, and that will show all the grants that have been created for a particular KMS key ID. It will also show you when this was created and the principle that it's allowed for and for which particular operation. Also, interesting thing to note here from a security standpoint is that there is no expiration for these grants, right? Even though the purpose of these grants is for temporary access, unlike the KMS key policies, which are supposed to be long-term, grants are in theory meant for temporary access, but there is no expiration by default, or by there is no feature to provide an expiration as well. So if you are a security auditor, if you do come across grants that haven't been revoked, the way to revoke them is using the revoke grants AWS command, and I can show you quickly how we can revoke this particular grant. So there you go, using the revoke grant command, we are able to revoke this grant. And then if I do the CP command again, I can see I'm back again to my previous error. So that's it for this lab. Thanks for watching Cloud Security Masterclass.